In the quiet vastness of space, where stars burn for billions of years and galaxies drift like islands of light, humanity has taken another bold step forward. The James Webb Space Telescope, after years of planning, construction, and calibration, has achieved something extraordinary. It has given us the clearest look yet at Proxima b, an exoplanet orbiting the closest star to our Sun. For the first time, what was once only a calculation, a dim trace in starlight, has been revealed as a world with visible features. Webb has transformed Proxima b from a mystery into something tangible, a place we can imagine. This is more than a triumph of engineering. It is a milestone in our search for life beyond Earth. For decades, scientists relied on indirect techniques to find planets around other stars. They looked for the subtle wobble of a star tugged by a hidden companion, or the faint dimming of starlight as a planet crossed in front of it. These methods revealed thousands of exoplanets, but always as numbers, not as worlds. Now, with Webb's advanced instruments, the veil has been lifted. Using its near-infrared and mid-infrared cameras, combined with specialized coronagraphs designed to block the glare of stars, Webb has isolated the faint reflected light from Proxima b itself. What emerged was astonishing. The image shows surface variations, some brighter, some darker, suggesting regions that could be ice, land, or even oceans. Atmospheric layers appear faintly around the planet's edge, evidence of gases scattering starlight. And perhaps most remarkable of all, hints of polar caps glimmer near its poles, a feature once thought impossible to detect at such distances. Spectroscopic analysis revealed even more. In the planet's atmosphere, scientists found absorption patterns consistent with carbon dioxide, traces of water vapor, and subtle hints of methane. These are not proof of life, but they are the very ingredients that make life possible. They suggest that Proxima b may not be a barren rock, but a dynamic, evolving world. The importance of this cannot be overstated. Proxima b lies within the habitable zone of its parent star, Proxima Centauri, a red dwarf located just over 4 light-years away. This is the region where temperatures could allow liquid water to exist on a planet's surface. With a mass about 1.3 times that of Earth, Proxima b is likely rocky, not gaseous. For years, this combination made it one of the most intriguing targets in astronomy. But until now, its true nature remained hidden. Webb's image changes everything. It shows us that exoplanets can be studied directly, not just as theoretical models but as real environments. Scientists can now move from asking, "Does this planet exist?" to, "What is this planet really like?" The implications extend far beyond Proxima b. Red dwarf stars, like Proxima Centauri, make up nearly 70% of the stars in our galaxy. If one planet around one red dwarf can be observed with such clarity, then thousands, perhaps millions, of others could be next. The possibilities are staggering. Behind this breakthrough is a story of human collaboration. Engineers perfected Webb's segmented mirror, capable of aligning to a fraction of a wavelength of light. Chemists and physicists designed instruments sensitive enough to capture faint signals across space. Computer scientists built algorithms to separate planetary light from the overwhelming glare of its star. And machine learning helped reconstruct the faint patterns hidden in noisy data, ensuring the final image was both accurate and detailed. It is not just a telescope at work here. It is the culmination of decades of vision, planning, and dedication. Behind every pixel of the Proxima b image lies the effort of thousands of scientists, engineers, programmers, and thinkers who pushed the boundaries of what humanity can achieve. Each mirror segment had to be polished with unimaginable precision. Each instrument had to survive the harshness of space. Every algorithm had to be refined to sift through noise and extract meaning. It is not a single discovery, but the collective harmony of knowledge, expertise, and determination that has allowed the universe to come into sharper focus. For the public, the impact is no less extraordinary. To look upon a world orbiting another star, just 4 light-years away, and to see it not as an abstract statistic, but as a real, physical place, alters our perspective in profound ways. Once, exoplanets were only concepts, distant shadows betrayed by mathematics. Now, they are landscapes we can imagine, with skies, climates, and terrains. For the first time, people can look at Proxima b and think, that is a world. That is a place we could stand on. It transforms astronomy from an intellectual pursuit into a deeply human experience. Scientists are already racing to unlock the secrets hidden in Webb's data. They are constructing sophisticated 3-dimensional climate models, simulating the circulation of winds across Proxima b's atmosphere, estimating how heat might flow between its day and night sides, and predicting whether storms or cloud systems could form. One of the most critical unknowns is whether the planet generates a magnetic field. On Earth, our magnetic shield protects us from the solar wind, preserving our atmosphere and making life possible. Without such a field, radiation from Proxima Centauri, a volatile red dwarf prone to frequent stellar flares, could strip away Proxima b's atmosphere and sterilize its surface. If Proxima b does possess this invisible shield, it dramatically increases the chances that it is truly habitable. The next steps in exploration are becoming clearer. Ambitious initiatives like Breakthrough Starshot, which proposes sending swarms of miniature spacecraft propelled by powerful lasers to the nearest stars, now have a defined destination. No longer would such missions be journeys into the unknown. They would be targeted expeditions, carrying instruments specifically designed to study Proxima b's atmosphere, its surface, and even its potential biosignatures. For the first time in history, interstellar travel is moving from the realm of imagination into the realm of practical planning. What was once thought impossible may, within this century, become reality. But beyond the technical challenges and scientific milestones lies something deeper, something profoundly human. For millennia, people have gazed into the night sky and wondered, are we alone? That question is etched into myths, philosophies, and religions across every culture on Earth. The image of Proxima b does not give us a definitive answer, but it narrows the distance between speculation and discovery. If this one nearby world shows Earth-like qualities, how many more must exist across the vast expanse of our galaxy? The odds that life has emerged elsewhere suddenly feel less like a fantasy and more like a statistical certainty. This moment is more than the unveiling of a picture, it is a promise. A promise that the cosmos is not an unreachable wilderness, but a frontier that we are beginning to explore. It is a reminder that the universe is not silent and empty, but filled with worlds waiting to be revealed, studied, and perhaps one day, inhabited. Each discovery carries us closer to a future in which humanity is not confined to one planet, but is part of a broader cosmic community. The James Webb Space Telescope has not only rewritten the textbooks of astronomy. It has redrawn the limits of human imagination. Proxima b, once only a flicker of starlight hidden in astronomical data, is now a place we can envision, alien, yes, but not unreachable. Its presence whispers to us that we are on the threshold of a new era, where discovery and exploration extend far beyond our solar system. And perhaps that is the greatest achievement of all. Not just the science, not just the technology, but the inspiration. The knowledge that in the darkness of space, new worlds are waiting, and that discovery belongs to those bold enough to look up, to question, and to dream.